Okay, this is whiteboard problem 29.2, and it says a wire carries a current of 1 amp. At what distance is the magnetic field of the wire equal to the magnitude of the Earth's magnetic field? And so the Earth's magnetic field is 0.5 times 10 to the negative 4 Tesla. So let's write our givens and finds first. So given, we have I is equal to 1 amp. We have the Earth's magnetic field, so we'll say B sub E for Earth is equal to 0.5 times 10 to the minus 4 Tesla. We are given our value for mu naught right there, or that's our, I guess, our known. And what we're trying to find is we're trying to find R in this equation. So what we know, this is our model. So right here is our model. The idea is that when we have a current carrying wire, anytime we have a current carrying wire, if we have current, then we have a magnetic field. And the idea for the model is that the magnetic field circles the wire. And we can figure out the direction it circles by putting our thumb in the direction of I, so up, our thumb is up, and then our B field at each point is along the theta direction. So in the front, it's to the right, and in the back, it's to the left. Okay, so our picture would just be, if we were going to do our picture, we would just have like a wire and show the direction of the current flow. And then our model is really showing that the B field circles the wire. So we're going to use this equation. B is equal to mu naught. So mu naught is 4 pi times 10 to the minus 7 Tesla meter per amp times I, which is 1 amp, divided by 2 pi times R. So right, we can't put any of that in yet, right? We need to solve for R on its own. So let's go back. So we're going to solve for R here. So what I'm going to do is I'm just going to multiply, like cross multiply, right? So I would do something like that, and I would say B times 2 pi R is equal to mu naught I times 1, so I'm just going to leave the 1 out. I'm going to solve for R, so R, I'm going to divide both sides by 2 pi B. So the 2 pi B then is canceled on the left, and it's in the denominator on the right, over 2 pi times B. And the B that I'm going to plug in is the B of the Earth, because that's what I'm trying to figure out. How far from the wire do I need to be to have the same field as the Earth's magnetic field? So if I plug in, I'm going to have, so mu naught is 4 pi times 10 to the minus 7 Tesla meter per amp times 1 amp. So my amps cancel there, so I'll just do that right now. And then I have 2 pi times 0.5 times 10 to the minus 4 Tesla. There we go. And so we can see my Tesla are going to cancel right there. And I'm going to be left with meters. So that's a good sign. I've got a length equals. So our pi's cancel here too. And I can cancel a 2. So I'll have a 2. So I'm going to have 2 times 10 to the minus 7 divided by 0.5 times 10 to the minus 4. All right, so let's see if I can remember that. If I go to my MATLAB, I'm going to have 2. Let's see, 2. Oh, how do I do? Let's say e to the minus 7 divided by 0.5, 0.5. Let's say e to the minus 4. What do we get? 0.004 meters. So let's see if we go back here. Did I forget anything? So 2 times 10 to the minus 7, I got that, divided by 0.5 times 10 to the minus 4. I think that was right. So 0.004 meters. I think that was my answer. Let's just look again. 0.004. Yep. Great. All right, so that's it. That was a pretty easy one. So that's my value for R.